Okay, so let's continue to solve mixture problems. So here's a algebra spice problem with the paprika and the cumin. Here was our setup, and how do we solve it? Well, we have a mix and match of things we can do. We can eliminate or we can substitute. So how about I just keep eliminating? So let's eliminate x. And so we have 1.3 is the coefficient for this x and 1 up here. So what I need to do is multiply by negative 1.30. Whatever I do to one side, I have to do to the other. Okay, so our new equation becomes negative 1.3x minus 1.30y. Bust out my calculator again, and what do we have? We have 16 times 1.30, and that's negative 20.8. So the other equation is 1.3x plus 2.25y, and 2 times 16 is 32. Okay, so we're off to the races there. Again, the x's cancel out. Here, you can line up your decimals, but I'll just go ahead and use my calculator at this point. So 225 minus 130, right, equals 995. So 0.95y equals, on the other side, we have 32. Oops, let me clear that out. We have 32 take away 20.8. So that equals 11.2. Alright, so we divide both sides by 0.95. And again, earlier I've been asking you guys to do this by hand, but let's just go ahead and bust our calculators out. And it looks like we get what? Let me clear that. 11, oops. So 11.2 divided by 0.95 equals, and it looks like we have 11. How about we round off to a couple decimal places? So it looks like 11.79. Right, this is ounces of cumin. Right, so back over here. So 11.79 ounces. Kind of a crazy number. So how much paprika? Well, again, we already know that x plus y is equal to 16. We just found what y is. So all I have to do is perform a subtraction to get my answer. So when we do that, let's see, 16 take away 11.79 equals 4.21. Okay, so 4.21. So for that algebra spice blend, they're going to need 4.21 ounces of paprika and 11.79 ounces of cumin in order to create the 16 ounces that they want at a $2 cost per ounce. Okay, so again, you kind of see that blend of the elimination method coupled with the substitution method. So a nice blend. For the next one, we had the oil and gas problem. So this one's not too hard. The numbers are nice. How about we eliminate x again? And so I'll multiply both sides by a negative 2. And so we get negative 2x minus 2y, and that's a negative 60. And on this side we have 2x plus y, and I think 1.5 of 30, I believe that's 45. Alrighty, and so adding things up, the x's cancel out. We're left with a negative y equals a negative 15. If we divide both sides by negative 1, we get y equals 15. So how many ounces of oil did they need? They needed 15. So what about the gas? Well, we know x plus y equals 30, and we know that y is 15. So subtract 15, and we get x equals 15. So they actually need 15 of gas and 15 of oil, right, to create the 30 fluid ounces, selling at $1.50. All right, and that's probably not a surprise because $1.50 is right in between $1 and $2. So it kind of, again, supports what we maybe intuitively already knew. So hopefully you guys are getting the routine. I think the last couple of word problems that we had dealt with percents. So let's take a look at those. We've had one that dealt with a nickel alloy and another that dealt with an acid solution. So here's the setups that we had for each. And again, how about we just continue to eliminate? How about we eliminate y this time to be different? So here we have a 0.10. So I need to multiply both sides by a negative, all right, 0.10. And so we get a negative 0.10x minus 0.10y, and I think 40, that's a point right there. All right, we're going to have to just move the decimal, and I think that would become a negative 4. And then we have a 0.15x plus a 0.1y, and let me bust my calculator out for that one. 40 times, times 0.12 equals 4.8. So if we do all our math here, the y's cancel out like I wanted to. We have a negative 0.1 and we're adding a 0.15, so that's 0.05x, and then 4.8 take away 4, well, that's a positive 0.8. So solving for x, I'm going to divide by 0.05, and again, let's go ahead and bust our calculator out to do that. You guys have earned that, being our last week and all, divided by 0.05. So it looks like 16. Okay, so they need, all right, for this problem, x was the amount of 15%, so we need 16 grams, right, of the 15% nickel solution to create the alloy that we want. How about the 10%? Well, let's go back and just make a substitution. So we know x plus y equals 40. We just found out what x is, so just subtract 16 from both sides, and it looks like we get y equals 24. Okay, so they'll need 16 grams of 15%, 24 grams of the 10% to get 40 grams of the 12% that they want. So again, hopefully you're seeing that nice rhythm going. Last one, how about we start by eliminating x again. The coefficients is 0.10, so I'll do the same thing. I'll multiply both sides by negative 1.0. Doing the math up here, we get negative 0.10x minus 0.10y equals, we're going to move the decimal, I think that's a negative 0.2. Right, if we move the decimal over once. And then over here, we just have, how about we just go there? So the x's cancel out, right? 0.35 minus 0.15 is 0.25y. And let's see, 2 times 0.15 equals 0.3. So this is 0.3. So 0.3 minus 0.2 is a 0.1. Alright, so dividing both sides by the 0.25, and again, it's been a long, hard summer, so you guys have earned the calculator. 0.1 divided by 0.25, right, equals 0.4. So y equals 0.4. Alright, so we need 0.4 liters of the 35%. We knew it was going to be small because my final solution is 15%, and that's closer to 10. So we need much more 10%. So to find that, x plus y is equal to 2. We just found out what y is. So we'll subtract 0.4 from both sides, and I believe we get 1.6. So we need 1.6 liters of 10%. So there's your mixture problems. That should wrap up Chapter 8. Again, if you guys are struggling, please post your attempts on Canvas. We can talk about them. I can catch your mistakes, or hit me up for a virtual office hour via Google Meet to try to get all this linear system stuff down. And as we wrap up our week, we got one more chapter. So I'll see you in those videos.